Thanks for joining us for Migration 2020. It's my great honor to introduce to you the Vice Chairman of the NTSB, Bruce Landsberg.
Thank you, Charlie. It's a pleasure to be with everybody today to talk about one of my favorite subjects, which is flying airplanes and teaching people how to fly. So let's start in with, what's a Luddite and what's an early adopter? And pretty much everybody knows what a Luddite is, or I should say an early adopter. I'm not so sure that they know what a Luddite is. And I find myself being on both sides of the coin here of sometimes thinking, well, the old ways are best. And then sometimes saying, we really ought to be trying something new. Now, before we get into all of this, just to be sure that everybody understands what NTSB does, most people know us for the investigation on site after a crash occurs. And we investigate across all modes: rail, pipeline, hazardous material, surface vehicles, and shipping. So it's not just aviation. The what usually is pretty straightforward. The more important part of what we do is to make recommendations so that we can take what we learned from the crash and hopefully prevent it from happening. Now, again, that's where most people think it all ends. But the NTSB's authorizing legislation allows us to do a much broader kind of thing. And we can do special investigative reports on this. And that can be on virtually any topic as long as it is factually driven. The last area, which is perhaps the most interesting for me as a board member, is of advocacy. And that is to talk to the regulators, because we are not a regulatory agency, to talk to the public and the industry to get those regulations adopted. So our flight plan for today, a rhetorical question. I hope everybody's going to be reasonable and see this my way, but of course that's not the case. Glass and automation play a huge part in what we're doing today, and there are some challenges in that area. I then want to talk to you about something that is so basic, and yet we continue to see it as an ongoing problem in investigations. And finally, a very important reminder for both you and your students to make sure that your certificate stays intact. So in terms of training challenges, we all know that flying airplanes is expensive. Sometimes it's only moderately expensive, and sometimes it's really expensive. Human capital, likewise, in the aviation business has always been a cost. Whether you're flying an aircraft, whether you're in a simulator, or whether you're doing online courses, such as what we do here, in any event requires a fairly high degree of skill. In the training environment, there are things that we would like to teach that are sometimes very difficult to do in the airplane. And some of them may involve fairly high risk, such as engine failures on takeoff. I have never been successful in duplicating an engine fire on an airplane in flight, thankfully so. The other challenge that we have is continuity with training. And if I used to tell my students, if you're not scheduling at least 2 to 3 times a week, it's going to take longer. And this directly affects our dropout rate. So if we were live right now, I would be posing this question to you. In fact, I will pose the question to you. What do you think the dropout rate is for somebody who's just starting to learn how to fly until they complete either light sport, sport pilot, or private pilot? 30%? 45%? The best estimate that we have is it's somewhere between 2/3 and 3/4 of people who start into training never complete it. And the really amazing part about that statistic is that it hasn't changed much in 50 years. So this gives us some real opportunities for improvement. Now, this is one of the most accurate cliches that flight instructors always lay out to students as we try to manage their expectations. The world's worst classroom. Well, the cockpit can be quite friendly, and I haven't noticed that pilots and students are getting any smaller. If you're flying in the summertime, certainly in the southern parts of the country, training flights seldom get above 3,000 or 4,000 feet, so it's going to be pretty uncomfortable. In the cold country, the airplanes don't like to be left outside, but that's where the training fleet spends a lot of its time. So engines may be harder to start. We've got to clean off the airplane, and it leads to, shall we say, abbreviated pre-flights. Now, one of the things that we like to do in teaching is to look for that teachable moment and say, now let's talk about what just happened. Well, the picture here on the right, you can see what happens if you try to stop the airplane in flight and have the discussion. It just doesn't work very well, so we have to postpone that discussion. Depending upon the weather and what you happen to be training at the time, turbulence can be a real distraction, and we may have to modify the lesson, or we may have to help the student get more comfortable. Now, I mentioned earlier about the potential for risk, and periodically we investigate crashes where somebody was doing some training and things didn't work out. This shows a engine pod being dragged on a large airplane, and this is precisely the reason why the airlines and most corporate jet operators will not train in their aircraft. They want to wait until they know that somebody has at least a modicum of skill before they put them in the left seat. Practice areas can be very high density, as are training airports, if you will. And so there's always the possibility for a in-flight collision. And finally, as we are focused on helping the student, sometimes we may miss an air traffic control call, or there's some nearby airspace, and that leads to, shall we say, entanglements with the regulations. So those are some of the challenges that we face in the world's worst classroom. Now, I already mentioned the fact that airplanes are capital intensive. Some of our training fleet are getting pretty old and pretty tired. They're not very expensive, but they're also worn out. New light airplanes have far outstripped the cost of inflation. I know this because I used to work for a manufacturer very early in my career, and I can tell you that the airplanes haven't changed all that much to justify the cost differential. Big airplanes, we've already talked about those, and there's a pretty good reason why we don't do a lot of training in them. Now, let's talk about the schedule continuity and some of the challenges that we face there. In order for a flight lesson to be successful, we've got to have all four of these elements. The student has to be available, the instructor has to be available, obviously we need the aircraft, and then the weather has to cooperate. And if it doesn't, any one of these things can wash out a lesson. But suppose we could eliminate two of those high potential scheduling conflict areas. You know where I'm headed, and that's with simulation. I want to be very clear, Redbird did not put me up to this. In my career, I spent over a decade working with one of the largest flight training organizations using simulators at all different levels, from the very basic to the very exotic. Good simulation is not inexpensive, but it is far less than the aircraft that it duplicates. So it allows us to do a lot of things that we probably shouldn't be doing in the airplane. So now we get into a little bit of a discussion of how should we conduct our training and in what kind of equipment? Well, let me start by saying that the US Air Force, which has a lot of experience in taking low or no time pilots and turning them into very high performance pilots, also with low time, starts their cadets off in gliders. And there's not a lot of glass in gliders these days. We may not have the access to gliders, but we certainly have access to more basic aircraft. So there's two kinds of ways of looking at this. You can look at it as the integrated method, which might say, look, you're going to be flying an airplane with all glass instrumentation. That's what you need to work on, and we'll kind of work our way through it. The other approach, which I happen to think is better and parallels what the Air Force does, is called the building block method, where we go from a much simpler situation to the more complex, introducing things as we go. Now, that doesn't mean that we shouldn't have at least some basic anti-collision technology on board and communications. And as you can see in these two pictures, that's available. The cockpit on the right has an iPad and of course full communication and collision avoidance. Am I being a Luddite here? Perhaps. So let's talk about what happens when we get too much automation or too much glass too soon in the training environment. There are three things that we really want to impart to the student early on. These items, which of course you are familiar with, but it all leads to basic energy management. If you want to see what a great job we're not doing on that, merely go out to any busy airport on the weekend and watch how the landings take place. And we also see it in the heavier airplanes as well, with the jets and some of the airlines. The pilots don't understand basic energy management. Obviously, communication plays an important part, and we want to work on that. This next item I cannot overemphasize, and that is we need to be spending more time on teaching the concept of angle of attack. It's basic to everything we do in flying. It's not really intuitive, and it's absolutely critical. All of this equates to what we refer to as airmanship. And again, if we were live today, I'd ask you, people in the audience, what does airmanship mean to you? And we'd probably get several different answers, but they might all sort of tend to converge on being able to put the airplane where you want to at the right time. So let's look at some airmanship failures at the top of the aviation operation pyramid. Asiana 214 was a Boeing 777 that flew all the way across the Pacific. There were two very experienced pilots on board, a 10,000-hour captain that was getting checked out in the airplane, and an even more experienced training captain, and yet another pilot sitting in the jump seat. And as luck would have it, it was a beautiful day in San Francisco. They had shut down the ILS, so they could not be able to fly an automated approach. Well, the crew said, all right, fine. We'll just use auto throttles and manipulate the controls on our own. Unfortunately, they didn't fully understand all of the modes of auto throttle. Now, the 777 has a superb safety record, and there have been literally hundreds of thousands, if not millions of landings using auto throttle. And yet somehow this crew managed to misprogram this, and nobody was watching the airspeed as you come in. And what do we have? A failure in airmanship and a very bad crash. This next crash, anybody who's considering a career in professional aviation should read the NTSB report. You can go to our website and look at it. There were 46 findings in that report. The crew was fatigued, too much commuting, too long. That's a whole nother discussion. The captain, having more than 4,000 hours, was new to the aircraft. He had just over 100 hours. He had a rather poor training record, which he didn't fully disclose, and he was also not using the sterile cockpit. So he and the first officer were engaged in a discussion on icing and a number of other things on a night instrument approach in a fully capable airplane with not unusual conditions in Buffalo, New York. The autopilot was on. They were descending to the initial approach altitude, and the autopilot altitude pre-select was set. Well, what happens there, very simply, is the autopilot will attempt to level the airplane off, and if you don't have auto throttle, it will slow down, attempting to hold altitude until finally the autopilot says, well, this is outside of my operating envelope, your aircraft. And the aircraft is just about to stall, which it did. The captain added lots of power and pulled the yoke back and held it all the way to the ground. What was lacking here? Again, airmanship. Well, that gets us into the whole challenges of automation, because sometimes when things are going wrong, we get a lot of fault warnings. And here would be some of the screens that you would see. I particularly like this one, which apparently the legal department thought would be helpful, saying that you should maneuver with care. I always try to maneuver with care. So as pilots, the two most common statements that we see when the technology isn't working right is this. The question we should be asking is, how does this work? And I really should know that prior to getting into a bad situation. Now, the designers are looking at things a little bit differently. They're wanting to know about the lines of code and the bugs and that sort of thing. Well, even in our light aircraft with glass cockpits, you have tens of thousands of lines of programming code, and on big airplanes, it will run into the multi-million lines of code. Are there bugs in there? I can guarantee it. And every time they do a firmware update or a software update, there is potential for introducing problems. We have seen it multiple times. Which is the perfect transition into an area that has lots of attention these days, the Boeing 737 MAX. And a lot of people say, well, why wasn't the NTSB more outspoken on this? Well, it's very simple. It wasn't our investigation. Both of the crashes occurred on foreign soil, and we are what's called an accredited representative under international law. So we can weigh in on the investigation, we can make recommendations, we can dissent, but it's not our place to lead the investigation. That said, we did make some urgent recommendations to the FAA prior to any of the final reports being released. And this was done over a year ago. We said that pilots could be overwhelmed, that the challenges apply to all aircraft, little airplanes as well as big airplanes. Of course, when somebody becomes task saturated, the troubleshooting is complicated, and we don't know as much about human factors in design as we'd like to think that we do. And when we talk about standardization, everybody seems to have a better idea on how to do things. Sometimes it works, sometimes it doesn't. I'd like to very quickly go through what the Indonesians found on their accident report. First, very obviously, there was a single point design failure that wasn't recognized. Now you will notice that I have an asterisk there. It was recognized by a number of Boeing employees and possibly some of the FAA. This was a very expensive mistake. Up to this point, it's cost Boeing over $19 billion with a B dollars, and FAA's reputation has certainly been tarnished. Additionally, transition training was limited to almost non-existent. I'd like to point out here that the board was invited to go fly the 737 MAX simulator, and we could fly it with the original software, the flawed software, and then with the new software. So I got the opportunity to do that. And I want to tell you, the airplane was fully controllable in both modes if you understood how the software worked and what you could do to overcome it. Critical point here. A 737 is a 737 except when it's a MAX. The trim deactivation is different on the MAX than it is on some of the others. Another critical point. When they're in certification testing, you have experienced test pilots and FAA certification pilots, and these people are on the top half of the bell-shaped curve. We shouldn't be designing systems for that. We should be designing it for the bottom half of the curve. There was no standardized methodology, and as I've already alluded to the fact, when one thing goes wrong in an automated airplane and it affects things downstream, there's a pretty good opportunity for confusion. Let's change gears now, and we'll go to one of your favorite ground reference maneuvers, the famous rectangular pattern. And the whole purpose for doing rectangular patterns is in pursuit of that elusive, perfect traffic pattern. Now, I have flown probably 15,000 or more traffic patterns in my lifetime, some of which I've flown, some of which students have flown, and I'm still looking for the perfect one, like Diogenes. So one of the reasons why we're having this discussion is that my government phone goes off whenever we have a fatal accident, and I would say probably twice a month, we will be having a fatal accident notification when somebody stalls out of the base to final approach turn. And the question is why? This is what the normal pattern should look like. But we need to be very careful because if we have a quartering headwind, that can pose some problems. And you say, well, how could that be? Headwinds are a good thing. Well, yeah, they are. In the green arrow, that's good. The red arrow says, okay, we're going to have some crosswind to deal with, and we are now focused on the crosswind at the runway. We really should be focusing on the crosswind on the base leg because it's going to force us perhaps to overshoot. And when we overshoot, we know what happens. People try to tighten the turn without steepening the bank, and they try to hold the nose up, and that's the outcome. How do we fix it? Simple. Adjust your traffic pattern. Move it out so that it's wider. And I can see a few people starting to shake their heads. And I would point out that we have all followed somebody in the traffic pattern flying a Cessna 172 or a Cherokee, and they somehow think they're flying a B-52. Now I realize that some people need to build up their cross-country time, but the traffic pattern is not the place to do it. Now, I'd like to move on to another area, and this is cannabis, pot, weed, whatever you like to call it. And it's been having something of a resurgence in the country. And all of the states have a slightly different approach on it. And this chart could be out of date very, very quickly. But let's not underestimate the enthusiasm for marijuana. And again, I'm not making this up. I actually took this picture in one of the cities that I happened to visit last year. Here's what we need to think about, though, as pilots. Federal law preempts all of this, not state law. And the law says, thou shalt not use, nor will you carry illegal drugs. Well, the drugs may be legal in a particular state, but they are not legal under federal aviation law. NTSB had a case come before us a few years back where a pilot had a minor crash on landing. It was a limited investigation from NTSB's perspective. We didn't send somebody out. The FAA was delegated to handle it for us, and local first responders, state police were there. And they were helping the pilot get some of the luggage off the airplane. And in the pilot's wife's purse were some packages of brownies. Not your normal kind of brownies. They were brownies that had been purchased in one of the states. And the trooper asked the pilot, "Do you know anything about this?" And the pilot said, "Well, I was kind of hoping you wouldn't ask me about that." Well, the trooper turned it over to the FAA, who said, "Well, okay, you're in violation of 91.19, and proceeded to revoke the pilot's certificate. The pilot appealed to the NTSB, and we had no room to maneuver there. The law is the law, and we can't change that particular situation. So better not to get there. Just don't do it. And if you are inclined to smoke the stuff, remember that if you have a toxicology test, which often we do after a crash, assuming you survived it, that marijuana will be in your system for weeks afterwards, which then will lead to a violation. The next area, which goes more broadly, and this affects your students and you for your medical certificate. The question at the top of the medical certificate form is, have you ever in your life? And then proceeds to list all kinds of things. I want to draw your attention specifically to question 18V, which has to do with alcohol and drugs, because we periodically will see pilots who have run across this and they're trying to finagle the situation in order to get their certificate. So, were you arrested? Well, yeah, I was arrested, but I wasn't convicted. Well, that doesn't count. You have to point out an arrest. Were there any administrative actions taken as a result of this? Was there what they call probation before judgment? Well, that counts. Okay, I'll go to an education or rehab seminar, driver's school, and you agree not to suspend my license if I complete the school. Well, guess what? That counts as well. So what if you did everything right and the state says, well, okay, you were good, you screwed up once, but you were good. We will expunge this from your record. Guess what? That counts too. And usually it's very hard to get any record completely cleared. When you sign up to get your medical certificate, including basic med, you give the FAA permission to search the National Driver's Registry. And they have a special unit to do this in Oklahoma City. And they match up people who are applying for medicals, and they go in and they look for this any situations that could cause a problem. So are there any exceptions in terms of what our options are if you break this rule? Very simply, no. So a word to the wise, be very careful. If you've had a problem, report it. Chances are pretty good. Yeah, there may be a small delay or something. In many cases, if it happened years ago, FAA won't say anything more about it, and that'll be the end of it. If you fail to report it, you run the risk of having every certificate that you own revoked. Not suspended, revoked. So let's summarize here what we covered. Using the right tools at the right time. I happen to think that simulators do a really good job, and we should probably be using them in some level in every kind of training because they are more effective at this. Automation and glass, I'm a believer in the building block method. Other people may prefer the integrated method. I think that's certainly open for debate. Personally, I will defer to what the Air Force has done. I was trained in very basic airplanes and managed to transition to glass without any major problems. We've talked a lot about airmanship. Please pay attention to the wind. Recognize that when you're teaching the rectangular pattern, that does not address what you're attempting to do in the traffic pattern. Rectangular pattern, you want to stay equidistant from the edges of the field. In a traffic pattern, that doesn't necessarily apply. Remember that federal law applies to aviation, regardless of how liberal a particular state might be. And on your medical applications, please, please, please tell the truth. You may consider me a Luddite. In some cases, you may consider me an early adopter. Again, it's a discussion that I hope we will be able to have at some point. I like to say that safety isn't everything, it's the only thing, because after a crash, the trip, the desire to get home, the business meeting doesn't matter anymore. Once people have been injured or the airplane has been badly damaged, it really doesn't matter. Thank you very much for your attention, and fly safely out there.